So our next topic in data link layer is Hdlc. What is Hdlc? Hdlc is high level data link control. High level data link control is a group of communication protocols of the data link layer for transmitting data between network points or nodes. Hdlc is most important data link control protocol. Also, it is the basis for many other important data link control protocols which use same or similar formats and the same mechanisms as applied in Hdlc. Since it is a data link protocol, data is organized into frames because everything here in data link will be in the form of frames. A frame is transmitted via the network to the destination that verifies its successful arrival. It is a bit-oriented protocol. Hdlc is a bit-oriented protocol that is applicable for both point-to-point and multi-point communications. The Hdlc protocol is an international standard that has been defined by ISO for use of both point-to-point and multi-point communications. And here in Hdlc we have different types of operation modes. The operation modes of Hdlc are, first one, those are nothing but transfer modes. We can say transfer modes. Hdlc supports two types of transfer modes. First one, normal response mode, and second one, asynchronous balanced mode. Okay. Coming to normal response mode. What is normal response mode? Here, in normal response mode, two types of stations are provided, a primary station and a secondary station. The primary station sends command and secondary station should receive the command and can respond to the received commands. It is used for both point-to-point and multi-point communications. This is used in unbalanced configurations. There are one primary station and multiple secondary stations also we can see. In normal response mode we can see one primary station and any number of secondary stations. This is nothing but multi-point communication. In normal response mode, the normal response mode is used for both point-to-point and multi-point communications. Here same as in point-to-point, here also primary station sends command to the secondary station and secondary stations receives the command and send back the response to the sender or primary station. Next comes asynchronous balanced mode, that is ABM. Okay, this is the second transfer mode for Hdlc. What is this? Here the configuration is balanced, that is each station can send both commands and respond to the commands. It is used for only point-to-point communications. Here in asynchronous balanced mode is used only for point-to-point communications and it is not at all used for multi-point communications. In ABM means asynchronous balanced mode, the configuration is balanced. The link is point-to-point and each station can function as a primary and secondary. Either stations, here we have station 1 and here is also station 2. Here either stations can send commands and can receive the commands. This is typical in connections between two computers and in X.25 interface standard. Okay, here station can send command or can get the send the response, and here also station can send the command or response. And HDLC. In HDLC is a bit oriented protocol where each frame contains up to 6 fields. Okay. Here both data and control messages are carried in a standard format frame. Okay. Here this is the HDLC frame. Here both data and control messages are carried in a standard format frame. 3 classes of frames are used in HDLC. Okay. What are the 3 classes that are used, frames that are used in HDLC? First one I frame, second one S frame, and third one U frame. What does U frame mean? U frame is unnumbered frame. S frame is supervisory frames. I frame is information frames. Okay, first, what is I frame? I frames or information frames carry user data from the network layer. Okay. They also include flow and error control information that is piggybacked on user data. The first bit of control field of iframe is 0. Iframe can be used to piggyback acknowledgement information relating to the flow of iframes in the reverse direction when the link is being operated in ABM, means asynchronous balanced mode. These carry the actual information or data and are normally referred to simply as iframes. Next comes S frames. What is S frame? S frames are supervisory frames. These are used for error and flow control and hence contain send and receive sequence numbers. Here S frames or supervisory frames do not contain information field. They are used for flow and error control when piggybacking is not required. The first 2 bits of control field is of S frame is 10. Okay. See. Here S frame, the first bit is of 10. Next comes U frame. What is U frame? Unnumbered frames. These U frames or unnumbered frames are used for myriad miscellaneous functions like link management. It may contain an information field if required. The first 2 bits of control field of U frame is 11. Okay, here it should be 11. Okay, next. These are used for functions such as link setup and disconnection. These U frames are used for the functions such as link setup and disconnection. The name derives from the fact that they do not contain any acknowledgement information which is contained in sequence numbers. Here we are telling us unnumbered frames. Okay, why we are telling unnumbered frames for U frames? Because it does not have contain any acknowledgement information like sequence numbers or anything. That's why we are telling U frame as unnumbered frames. Okay. And next comes HDLC frame. What is HDLC frame? HDLC frame is a bit oriented protocol where each frame contains 6 fields. Okay. HDLC uses synchronous transmission. All transmissions are in the form of frames only. The structure varies according to the type of frame. The fields of the HDLC frame are flag, address, control, payload and FCS. See, flag, address, control, payload, FCS. What is FCS mean here? FCS is nothing but frame check sequence. Okay. And coming to one by one. What are flag fields? flag fields. It has a unique pattern at both the ends of the frame structure. Here this frame is starting and ending, we have flags. Okay. It identifies the start of the frame and end of the frame. The length of the flag field is 8-bit. Okay. It is an 8-bit sequence that marks the beginning and end of the frame. The bit pattern of the flag is 0, 1, 1, 1, 1, 1, 0. And next comes address. Okay. What is address? It contains the address of the receiver. If the frame is sent by the primary station, it contains the address or addresses of the secondary stations. If it is sent by the secondary station, it contains the address of the primary station. The address field may be from 1 byte to several bytes. And next, control. It is 1 or 2 bytes containing flow and error control information. Control fields contain frame numbers. Also, it controls the acknowledgement of frames. Control field is 8 or 16 bits in length. Next one, payload. What is this payload? This carries the data from network layer. Its length may vary from one network to another. Data fields contains the user data received from the network layer. It can be variable length but in integral number of octets only. Next, FCS. It is 2 byte or 4 bytes frame check sequence for error detection. The standard code used here is CRC, cyclic redundancy check. FSC is an error detecting code calculated from the remaining bits of frames. FCS can be 16 bits or 32 bits long. Okay, this is Hdlc. Thank you.